class. Today we will discuss on the following objectives. The first objective would be the distribution of the forces on the body. Thereafter we will study on the concept of stresses, the different types of the stresses that are known as the normal stress and the shear stress. Thereafter we will define a general state of a stress in the context of a beam. Distribution of forces on the body. So this one is a body. This body can be subjected to a number of forces, or different kinds of the forces. The first type of the forces can be concentrated force. The second types of the force can be linearly distributed forces. The third type of the forces that can we have is the surface forces that are acting on the surface of the body. So we can define that the external loads that we are interested can be idealized, or it can be categorized into different types of the forces. The first forces would be the concentrated force. The second types of the force can be the surface force, or it can be the linearly distributed load as it is shown in the figure. Under the actions of these loads, these loads means these forces, the body is deformed. So these forces will have a tendency to deform the body, but in this course of the advanced solid mechanics, we will consider the body to be deformable. Other types of the body can be, it can be the rigid body. So how do we define a rigid body? A rigid body is a type of the body which cannot deform. Even if we apply a larger values of the forces, these types of the body will not have a tendencies to deform. So we don't have any types of the strain. So if we don't have any strains, we will not have any stresses in the bodies. So under the conditions of the deformable body, there are internal forces that holds the body together. Stress. So this one is a body. This body is subjected to different types of the forces. Say F1 is one type of the forces, F2 is other types of the forces, F3 is different types of the forces, and F4 is different types of the forces. So this body is subjected to different types of the forces, and we are interested in defining the stress at a point. For that we will cut this entire body into a with a sections, that are plane sections, and thereafter we will define the forces that are acting on a particular sections. So when we cut it with a sections or a plane, this particular sections, this particular sections will be subjected to different types of the forces. The values of the forces will be in the different directions, because we are always interested in defining a stress at a particular point. So at a given sections, so this one is the sections we have taken, this particular sections. The internal forces are distributed as shown in the figure 1b. These are the internal forces that are acting at a particular sections. This particular sections comprises of the different points. These different points, say this one is the first point, this one would be the second point, and so on. There are number of points on which different types of the forces are acting. The different resultant values of the forces that are acting at different points on a particular sections, and we find the resultant of the internal forces at a given point O as shown in the figure 1c. So among different points, so this is the first point, this is the second point, there can be other point, the third point. So there are infinite numbers of the points. At this particular point, we say we are interested in finding the stress at a particular point. Say that point is O. So at this point O, a number of planes can pass. So this one is the first plane shown by the red line. The other plane can be the lines shown by the violet colors. So at a particular point there can be a number of planes, infinite numbers of planes passing through this particular point. Let us define what are the stresses that are acting at a point O when we consider the plane that is shown by the red color. So at a particular point O, say this is the point O, the force can be normal to this body. Say this is denoted by sigma n. Sigma is the normal force that are acting perpendicular to this plane. The other types of the forces that can act is along the directions of this plane. Say this one is that force. It is represented by the shear force. Say the shear force is denoted by tau, and at a particular point as two forces are acting, one is acting normal to that point and the other force that are acting, it is acting along the plane of the line. So the resultant force, so there will be a resultant force which will be the resultant sum of the different forces. First force is the normal force and the second one is the shear forces. So at a particular point, so we will have a resultant one force acting at a point O when we consider a particular plane that is shown by the red color. Next, if we consider the plane to be the line shown by the violet color, in this case, if again we are interested in finding the resultant of all the forces that are acting at the point O, but we have considered a different plane. In this case, again we will have a normal stress that is again shown by the sigma n. Say it is sigma n1. There can be the values of the normal stress will be different if we consider the different planes. The other types of the force can be the shearing force that is acting along this plane. Say that force that is acting along the plane is tau 1. These two values, sigma n1 and sigma and tau 1, may or may not be same, or it can be different of the forces that are acting when we consider the plane shown by the red color. So again we will have a resultant force that is acting at a point O. If we choose a plane that is shown by the violet color, say this resultant force that is acting, it is R2. So if we consider the different planes passing through the same point, we will have different values of the resultant. So if this is in context with two particular planes, so at a particular point a number of planes, I should say infinite numbers of planes can pass, and infinite number of planes passing through a point O, we can have infinite resultant of the force that is acting at a point O with different values of the normal stress and the different values of the shear stress. So the distributions of the internal forces, these internal forces that are acting at a given point of the sectioned area of the body can be determined by using the concept of stresses. Now let us define again, extrapolate what we have studied in the context of the stresses till now. So this one again is the same body. Now we are interested in finding the stress at a particular point. So the area which we have to select has to be very small. We are interested in finding the stresses at this small area. The extrapolated figure is shown over here. So this one is a small area delta A. At this particular area, a force is acting normal to this plane or this area. That force is known as this force is known as the normal stress, and with the force that is acting along this plane, so Ft, it is known as the shear force or the shear stresses, the resultant of these values, the normal stress and the shear stress, is represented by delta F, which is the resultant of these two forces. The stress describes the intensities of the internal forces on a specific plane. This specific plane we have selected, this planes which we have selected, this is the plane which we have considered, or area passing through a point as shown in the figure. This is the small area that we have considered. Again, at this particular small area, different types of the forces can be acting. So the different types of the forces and the corresponding stress can be classified into two types. So it can be classified into two types based upon the actions in which it is acting, or the directions in which it is acting. The first types of the force is the normal stress. So the normal stress is this represented by delta Fn. Why? Because it is acting perpendicular to the surface which we have selected. And the second types of the stress can be shearing stress, represented by this force, because this force is acting along the plane which we have selected. Since the stresses generally vary from point to point, so we can say that there are different numbers of the points, or we can say there are infinite numbers of the points. So we should define the stress at a particular point, and the definitions of the stress must relate to an infinitesimal, very small element. So we define the normal stress acting at a particular point. It is represented by sigma, which is delta Fn, the forces acting in the normal directions, and the area which we have selected under the limit when delta A tends to 0. The second types of the stresses, we can have the shear stresses. Again, that delta Ft is the force acting along the directions of the planes which we have considered. It will be parallel to the plane, and delta A is the area which we have selected. We are interested in finding the stress at a particular point. In that case, that point has to be very small. In that context, delta A tends to 0. So at a particular point we can have two stresses. The first stress would be the normal stress, and the second one would be the shear stress. Normal stress is the stress that is acting perpendicular to the plane which we have selected, and the shear stress is acting along the directions of the plane which we have selected. As we are working in three dimensionals, that is three directions we have x directions, y directions, and z direction. So when we are defining the stress at a particular point, we will have one values of the normal stress. Normal stress is acting perpendicular to the area that we have selected, and we will have two values of the shear stresses. One values of the stress is acting along the y directions, and the other values of the stress that is acting along the x direction. So the small area which we have selected will be subjected to three types of the forces. One force will be the normal stress, and we will have two values of the shear stress that is acting at a particular point. That point is very small. We tell it that the area of that element which we have taken is very small. Over here, the first values of the stress, which is the shear stress, is acting along the y direction. So the first subscript over here represents the directions of the plane normal. It is z. Why? Because this plane is always defined by its plane normal, and second subscript y denotes the directions of the stress in which it is acting. Again, similar to this, the second values of the shearing stress that we can have at a particular point. Again, the first subscript represents the plane. Again, the plane is defined by its plane normal. This plane is defined by a plane normal which is directed in the positive z directions, and x represents the directions of the stress that is acting. So the stress is acting in the positive x direction. This is what is shown in this figure. The area which we have selected is very small, delta A. The normal stress that is acting at the particular small area which we have chosen is delta Fz. So the stresses is when delta Fz divided by the small area which we have selected. Again, the second values of the stresses that is acting at this particular point is the shearing stress. This stress is acting along the plane which we have selected. If we are interested in finding the stress at a particular point, we will define these values of the force by a particular small area which we have selected. The other values of the forces that are acting at the particular point which we have chosen, this point which we have chosen is delta Fx, is the force acting in the x direction. If we are interested in finding the stress at this particular point, again we need to define this force by, if we are interested in finding the stress at this particular point, we will say delta Fx divided by the small area which we have selected. So in conclusion, what we can say, at a particular point we can have two values, one values of the normal stress and two values of the shearing stress acting at a particular plane. Let us define now what is the normal stresses. Normal stress, or it is represented by sigma, is the intensity of the force that acts normal to the area delta A. So this force will act perpendicular to the small area which we have selected. If the normal stress or stress pulls the area delta A, it is referred as the tensile stresses. If this has a tendency to of pulling this apart, then we will consider these forces as the tensile forces, whereas if it pushes the area delta A, it is referred to as the compressive stresses. So the normal stress can be divided into two types. First one is the tensile stresses, when it has a tendency to pull apart. When it has a tendency to compress or push in, it will be termed as the compressive stresses. So it can be defined as sigma zz. It is the normal stress. It is defined by delta Fz, is the force acting in the z direction divided by the small area which we have selected. This small area has to be very small, very small. So this limit of delta A tends to 0. Second types of the stresses that we can have is the shear stress. It is represented by the tau. It is the intensities of the force that acts tangent to the area delta A which we have selected. Again, this delta A is the small area which we have selected. So at a particular point, we will have two values of the stresses on a particular plane. So the first values, that is tau zx. Again, the first notation represents the directions of the plane normal, and second represents the directions of the stress at which it is acting. It is again defined by some of the directions of the force in which it is acting divided by the small area which we have selected. Again, this area has to be very small, so limit of delta A tends to 0. So this is the first values of the shear stress that is acting on a particular plane. The other values of the shear stress that is acting on a particular point is given by tau zx. Z again represents the directions of the plane normal, and y represents the directions of the stress in which it is acting. So the direction of the stress that is acting is in the y directions, positive y direction, and it is acting along the area delta A. Again, this delta A tends to 0 because we are always interested in finding the stress at a particular point, and that point has to be very small. So our limit of delta A has to tend to 0. So to conclude, we can have three values of the stresses at a particular point. One value of the force will be the normal stress that is acting perpendicular to the area which we have selected, and we will have two values of the shear stresses on the area which we have selected. Let us define the general state of stress in case of a beam. So this one is a beam. This line shown by the black bold letters, black bold line sketch is the low beam which is being represented over here. This is the different types of the supports we can have. Now in case of the beam, we are interested in finding the stress along a particular plane. So the plane which we have chosen over here is this plane. Again, we are interested in finding the stress at a particular point. That point has to be very small. Then at this point we can have a values of the normal stress that is acting perpendicular to the plane that we have selected, and other value would be the shearing stress that is acting along the directions of the plane which we have considered. So the two values of the forces are acting. First one is the normal stress and the second one is the shearing stress. So the resultant of the forces, the values of the normal stresses and the shear stress is represented by under root sigma square plus tau square by using the Pythagoras theorem. So the resultant force that is acting at a particular point, this point, say this point is represented by point P, is root under sigma square plus tau square. Again, we have chosen of this particular plane. With that, we have got a values of the resultant force that is acting at a point is this value. If we choose a different plane, the different planes can be this plane, then we will have again the different values of sigma 1. Say this value is sigma 1. We will have different values of the shearing stress that is acting along the plane, that would be tau 1. Again there will be the resultant force that is acting at a point P. This would be in this direction. This values and this value would be given by sigma 1 whole square plus tau 1 whole square. So at a particular point we have different values of the resultant when we consider the different planes we are selecting. So the normal stress again in this case is defined by letter sigma. It is the intensities of the force that acts normal to an area which we have selected. Delta is the area which we have selected. So we have defined the values of sigma as delta F. This arrow represents the force that is acting perpendicular to the surface which we have selected, and delta A is the small area which we have selected. Again, we are interested in finding the stress at a particular point. That point has to be very small. Under that circumstances, delta A has to tend to 0. The second types of the stress that we can have thus to the plane which we have selected is the shearing stress. It is the intensities of the force that acts perpendicular or acts at the tangent to the area which we have selected delta A. The shearing stress is given by delta F is the force that is acting along the plane, and delta A is the area which we have selected. Again the same thing, delta A has to tends to 0. If we are interested in defining the stress at a particular point, that point has to be very small. So the learning outcomes of this sessions would be the different types of the forces that can act on a body. We have studied about the different types of the forces a body can be subjected to. It can be a concentrated force, it can be a linearly varying force that is acting along the line, or it can be the surface force that is acting on the body. Thereafter we have defined the stresses and the types of the stresses, the two types of the stresses that are acting on a small elemental area. Delta A is the normal stress that is acting perpendicular to the area which we have selected, and the shearing stress that is acting along the area, a small area which we have selected. And thereafter we have defined the general state of stress in case of a beam. So this is all for this session. We will meet you again in the next session. Thank you.